So students, now we are going to look out the question number 2 student, right? So let's see the question number 2 here. Question number 2 are over student. So third one we are going. Third one they are saying student, on the fourth position tertiary butyl is there, 3-iodoheptane is there student. Now you should know student what is the formula of heptane, that you should know. So hept means how many carbon student? Hept means going to be 7 carbon, right? Hex means 6 carbon, pent means 5 carbon, oct means 8 carbon, non means 9 carbon, dec means 10 carbon. So dear student, what we are going to look here, that is heptane is there. So firstly you write the hept student. This is the 1, here is 2, this is going to be 3, this is 4, here is 5, this is 6, and this is the 7. Let us number student 1 2 3, this is going to be 4, here is 5, 6 and 7. Up dear student, on the fourth position what is there student? Tertiary butyl is there, and fourth position tertiary butyl is there. Means let's try to write the go on the fourth position student and try to write the tertiary butyl. So fourth position, how can you write student? Butyl means 1 carbon here, then this is CH3 student, this will be CH3 student, and here is also CH3. So this is the tertiary butyl student. Now you see fourth position tertiary butyl, 3 position are what is there? Iode is there, iodine is there. So here we are placing what student? I. Now all the valency of carbon we have to satisfy the student. So first position only single bond is there. So how many hydrogen required? 3 hydrogen. Here is 1 hydrogen, 2 hydrogen student. This place 1 hydrogen. Here is what is there student? 1 hydrogen. This is going to be 2 hydrogen. Here is going to be 2 hydrogen, and this is also going to be 3 hydrogen. So this is what is our required answer student for the third option, right? Now what we are going to look over the next one student. So fourth one we will go and look the fourth one. Actually student, what I tried to go on the live, but I think the live is not starting. That is what the problem. Now it started, but I try to be live students. Okay, so it is running, of course it is running. Yeah, I think it is running. Thank you. Okay, so if you see here, actually this is my first okay streaming. I didn't do much of this one, so it may be difficult, but I don't know where one can find this streaming, right? Because we have to, okay, what else I can do? Let's see the next one, fourth one student. Fourth one, to go fourth one, I have to erase this one also, because the space here is not that much student. Okay, so student, what is the fourth one? They are talking about 1,4-dibomo bute 2-ene. So what is going to be bute student? Bute means 4 carbon. So 1, here is 2, because here you see single bond we can not place, but or whatever the hydrocarbon will be there, single bond automatically it will be there, whether double bond or not. So firstly you draw the bute student. So here we wrote the bute. Now you should number here also. So 1 2 3 and 4 carbon is called bute. Now you check out student, the second position what is there student? Ene is there. So from the second position we place the ene. Now on the first position and fourth position what is there? What student? Bromo. So here it will be the what student? Bromine, and here if you are going also it will be bromine. Now the valency of carbon has to be satisfied also. So now how many valencies are carbon is there? 1 and 2. So here 2 bond more required, student. So here is H2. 1, 2, 3 are there. Here you can place H. This is also going to be H. Here is 2 bond is there. So 2. So this is 1,4 dibomo butene, student. Now we are going to look out the last one, student, here. So what is the last one, student? You check out the last one, right? So dear students, if you are going the last one, what is said, student? 1 bromo 4 secondary butyl. See, keep in mind, it is not the tertiary. Here it was the tertiary, student, 4 tertiary, but here they are saying that is on 4th position secondary butyl, means 2 degree butyl, obviously 2 methyl benzene. So first of all, what is the word root, student? If you can understand, here is, this is the butene, student. This is going to be the word root. Benzene is going to be word root. Now, student, on the first position, firstly you can mention out the position. Here is 1, this is 2, this is going to be 3, here is 4, this is 5, and this is 6. So on the first position, what it is going to be there, student? That is what is bromine. So 1 bromo is there. On the 4th position, secondary butyl is there, student. So here is CH. Okay, CH, why I am writing, student? Because this is the alpha carbon. Alpha carbon must attach with the 2 carbon, student, so that it can be the secondary butyl. Otherwise it cannot be the secondary butyl. Okay, so here is CH2 and this is the CH3. This is the secondary butyl. Alpha carbon attached with the 2 carbon, student, 1 and 2. So this will become secondary. And now total carbon is 4th, student. So it will be what, student? That is the butyl group. It will be the butyl. So it is correct, student. 1 bromo, 4 secondary butyl, 2 methyl. On the second position, what is there, student? This is also there, the CH3 group. That is methyl. So 1 bromo, 4 secondary butyl, 2 methyl benzene. So that is correct. Now we are going to move on the second question, students. So let's try to understand what is the second questions. Okay. So somewhat, see, student, H2S, why sulfuric acid is not used during the reaction of alcohol with the Ki, right? Student, what is happening if you see now? So if you are talking about H2SO4 and treating with the Ki, right? So H2SO4, what it is going to oxidize this one into what, student? It is okay, it will be, if you are talking about Ki, so it will convert into Hi, student. So let's see, I am taking the 2 Ki, student. So if you are mentioning 2 Ki, so it will give 2 KHSO4, and it will give, student, 2 Hi, right? Now Hi also, see, student, Hi is also going to be reacting. So H2SO4 is there, student, and here is also writing 2 Hi friend. So what will be there, student? So it will convert into 2H2O, you can see 2H2O plus I2 plus SO2. Now, so Hi will not be available for the reaction with alcohol to form alkyl halide, right? So that is why the sulfuric acid is not used during this reaction. It is acting as a oxidizing agent, student. Here if you are talking about, this is -1, so it is 0. So what is happening? It become the oxidized, okay, and to get react with the alkyl halide, student, okay. Suppose we are having the RCl, and if you are treating with the Hi, so it can go the RCl, right? It's Ri plus HCl. But what is there, student? In the reaction, it is there I2 do not react, student. So we are having the RCl plus I2, okay. So here is no reaction. So what is happening? Since Hi is converted into what, student? Hi is converting into I2, so it is not available. Hi is not available, so it will not give the reaction. So that is what the our required answer. Now second one, write structure of different halogen derivatives of propane, student, right? So that is very simple, student. So halogen derivatives of propane we have to make. What is the derivative, student? Derivative means from where we are going to derive the haloalkane, or that is, okay, so we have to replace the hydrogen, right, student, hydrogen with the help of the halogen. Now let us see, student, here. So what is there, student? Propane. So here is CH3, this is CH2, and this is going to be CH3, right? So firstly what we can do, student, okay, you treat with the Cl2 in the H mu light, H mu light. So what the possible structure you are going to get? And they are saying different dihalogen derivatives of propane. So where this compound, halogen can go, student? So firstly, if you are going, student, in this case, so either halogen can attach, there is a possibilities. So what possibilities is there, student? That is CH3, okay. Here it can be Cl, student, or it can be Cl here, student, and this is CH3. So that is the first case. This is the case 1. Now let's try to understand case 2, student, H mu, because we are going to give the substitution reaction, student. Derivatives means substitution, okay, derivatives means substitution. So second case you can write here, student, this can be the Cl, here is the CH2, then it can be CH2, and here is the Cl. So this is the case number 2, this is the different compound. Now case number 3, student, you can make the Cl here, student, then CH2, okay. Here the next one, it can be the Cl can go here, student, Cl, right, and here is again CH2, CH3. This is the one case. Now the last case is also possible, student. The last case, this is the case number 3. What the last case possible, student? Both the hydrogen can go on the first position, right? So here will be the CH, this is the CH2, and this is the CH3. So both hydrogen, if you are talking about the cases, you see, student, what are the cases are there? So first case, both halogen are the what position, student? Both halogen second position. This is 1, 2, and 3. Both halogen second position. Both halogen, what are their first and third position? Both halogen first and second position, and both halogen on the first position. So total derivatives what are possible, student? That is 4, student, right? So this is all about the answer, student. Now what we can do next, student? What we can do next? So question number 4, let's see the question number 4. Among the isomeric alkane of mono molecular formula C5H12, student, identify the one that on photochemical chlorination yield a single monochloride, student. So this is also quite simple, student. Yeah, let me erase first, student, to see if the all the halogens are same time, student, same type. So they are going to give the similar product, student, that you need to keep in mind, okay. Same time means that is what similar product is going to be obtained. If all the hydrogen are identical, the product is also going to be identical one. So here 6.4 we are good dealing 6.4. So what are the compounds? C5H12 is there, C5H12, right. So here is, student, first one, a single monochloride, student, single monochloride. So if all the hydrogen, you can make like that, student, CH3, this is what is CH3, this is what is CH3, and this is what is CH3. Whether you talk about the which one, student, you talk about the this hydrogen, 3 hydrogen, or you talk about 3 hydrogen, 3 hydrogen, 3 hydrogen, all hydrogen are, if you talk, all hydrogen are identical. So since all the hydrogen are identical, so what, student, all hydrogen are identical, so it is going to be what, student? So all hydrogen are identical, so it will give single monochloride. What, student? It will give single monochloride, right? So this is what the first one. 3 isomeric monochloride, the second case they are saying, student, C isomeric monochloride, student. There are student, I have no idea how to do this all, just learning this one, right? So although it is showing live here, but I don't know it's working or not, that is what the problem. Let me share it on Facebook, okay. And here this we can share on Twitter also. Okay, come to the same point again, student, where we were. Now the next one, 3 isomeric monochloride. So 3 different type of what, student, hydrogen required. So out of this, how can you make 3 different type of hydrogen? Okay, so let's try to look over it, student, for the 3 different type of the what is called, student, hydrogen. So dear student, you see here, so 5 carbon are there now, student. You can make CH3, here is you can make the, this is also CH3, this is CH2, and there is CH3. Ab student, see, total carbon is how many are there? 5 carbon are there, na? 1 2 3 4 5, that is correct. Hydrogen 3 3 6 7 7 5 12. Now these hydrogen are identical hydrogen, okay, these hydrogens are identical. Now this is also identical, they are all methyl group, student. So all methyl group, any of the hydrogen you are replacing, you will going to get the similar compound, student. So now, so from, if you are replacing any of the hydrogen here, so you are going to get what, student? One type. This is going to get one type, right? Here you can replace, student, because if you consider this alpha, this is beta, and this is gamma, right? So these are the methyl group are the same, these all the methyl group are same, so you can replace anyone. Either you can go the other way. What other way you can go? So you can replace any position here, second position, so you are going to get the similar product. Now So one, this is the different hydrogen student, this is the different hydrogen, and this is also different hydrogen. So total different hydrogen are how many are there? 3 hydrogen. So this is compound is going to give 3 isomeric monochloride. Now next one is they are talking about 4 isomeric monochloride student. So what we can do for the 4 isomeric monochloride student? Okay, let us see student. So let me see, the first one we draw here is student, this is CH3 where all the hydrogen are identical, CH3, and second structure is what is possible student, CH3, CH2, 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 CH3, we can make this one second case. And last one is student, last one we are going to make CH3, C, here is CH3, this is the hydrogen, this is the hydrogen, and this is the hydrogen. Now you can count out this one student from the A, B, C. So if you are talking about A, B and C, so this compound is also going to be AB type, so it is going to be AB. So total 3 different are there, so 3 isomers you will get here, 3 isomer. Here is what student? 1, okay, isomer. What about out of this student? If you count out this one student, so here you start A, this is B, here is going to be C. Now if you check other one student, this is the D also, and here is going to be A. These are the same. Which are the same student? Which are the same? If I will ask you, which are the same? These two are the same, that is called A. So total 4 different type of hydrogen are there, so it will give the 4 isomer student. So last little bit I did mistake earlier. Now the next one is student, here question number 6.5. What is the question number 6.5? If you are treating this one, so alcohol are there, if you are treating with the thionyl chloride, it is going to give student simple product student. Alcohol will convert into here Cl student, then it is going to give SO2 plus it is going to give Cl2. This is there student. Now the second one, if you are treating with the heat student, heat, it is the heat, so UV light is there, so it will give the substitution reaction. So double bond it cannot affect, so it will go on this carbon student. So let us draw the product, dear student. How can you make the product here? This is the what student, NO2 group are there. So here will be what student, CH, this place will be Br, and here will be the CH3 group student. Now you go with the HCl, dear student. If you are treating with the HCl student, so HCl, here the partial double bond character is there, so it cannot do effect here. So here it will be replaced student. Where it is going to replace student? Where I am writing the product. So it is going to be CH2 and Cl student, and here OH will be not disturbed student, because of the partial double bond character student, they cannot affect the phenolic group student. So that is correct student. Now come out this one, HI student. This will give the addition reaction student according to Markovnikov rule student. So I will be going to here student, and H is going to on this position, because what the Markovnikov's rule says student, negative part of reagent will go add on the that hydrogen which have less number of carbon student. So this is the hydrogen, and here it will be the iodine student. So this is what our required answer. Now you go with the NaI student. So this is what the halogen exchange reaction student, halogen exchange reaction. So if you are treating with the halogen exchange reaction, so it is the iodine will be exchanged student. So it is the Finkelstein reaction student, Finkelstein reaction. So it will be what student, CH3, CH2, and this is going to be I. Now here you are heating student and treating with the bromine. So if you are heating and treating with the bromine, so it will give substitution reaction student, substitution, not the addition student. Addition means the double bond can disappear, but it is going to give student substitution reaction. So one bromine will be attached here student, and double bond will be as it is. So this is our required answer. Now let us go and move to the next problem. I need to see the next problem student. What are the next problem? So all the question we have done, I think. Yeah, question number 6 I got here student. Okay. So dear student, if I will go and answer these questions, so what is firstly, they are saying arrange each set of the compound in order to increasing boiling point. A boiling point is what student? Boiling point proportional to molecular mass, mm. Second, boiling point is inversely proportional to branch. If branch is more, so boiling point will be less. Okay. So now the first one you see student, first one please. So bromomethane is there, bromomethane, CH3 and Br is there. Bromo from student, second one, what is there student, second one, CHBr3, bromoform. Third one, what is there student, chloromethane, 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 CH3Cl. Now fourth one, dibromomethane student, what is there, dibromomethane. So here it will be CH2, this is the dibromo, here is Br and this is Br. Students, see the highest mass will be this one, okay, bromoform, because 3 bromine is there. And if you check the mass of bromine atom student, it is something the 81 student. Let me check student the mass of bromine atom, then I will tell you. Mass of bromine. So mass of bromine atom 80, right? So how can you add here? You see student, carbon is 12, then 3 hydrogen student, and 80. So the first case you can add student. So how much you are going to get student? See, 12 plus 3 student, this is 15, plus how much we are having, 18. So it is simply, it is the 95 student. Now second one student, 12 plus 1 plus 3 bromine are there, so 240 student. So how much is there student? 240 plus 13, it is going 253 student, 253. Now chlorine, here is 12 plus 3 plus what is there student, chlorine, 35.5. So 15 plus 35.5, it is 50.5 student. What is there? 50.5, this is there. Now the next one is student, 12 plus 2 plus bromine, how much is there student? That is 160, right student, 160. 2 bromine is 160. So 160 plus 14, it is going to be 174. Up dear student, what the order you will write student? The highest will be chloroform, CHBr3. What increasing order they are asking student? Increasing order. So firstly you write down the least one, whichever will be the mass is least student. So this one 50. So the CH3Cl, it is having the least mass student. Then it will go 95 student, CH3Br. Then it will go student, how much? 174. So this is what student? Dibromomethane. And the lastly student, which one is going to be bromoform, CHBr3. This is what? Increasing order of boiling point, increasing order of boiling point, order of boiling point. So this is what now so I hope it will be the clear to you, very easy. Now the second one is student, dear student, you can do here on the upward side. So second one, see, 1 chloropropane, 1 chloropropane. So Cl is there student, this is CH2, here is CH2, this is CH3, 1 chloropropane. Then what is isopropyl chloride student? CH3, this is CH, this is CH3 and here is Cl, isopropyl chloride. And 1 chlorobutane student, Cl, CH2, this is CH2, this is CH2 and this is CH3. So here 1, 2, 3, 4. See, here will be, you see the larger compound, na, high molar mass. So this will be on the first position student. Then it cannot be the second because here branching is there student. It cannot be 1, 2, 3, 1, 2, 3. But here the branching is there. So student, how can you write the order student? Cl, here will be CH2, CH2, CH2 and here is CH3. This is the first one student. Then here is Cl, here is CH2, this is CH2 and CH3, second one student. Now friend, see, the last one is what will be there here, least boiling point, this compound will be there. Okay, so this was the based on the branching student. Okay, so this is the increasing boiling point, increasing, okay, increasing order of boiling point student, order of boiling point, boiling point. Now student, what we are going to do, the next one we are trying. Here this is the good question student, right? Let me check student whether I am being on live or not. Okay, I shared some places but it is not showing on the YouTube. I don't know why students. Yeah, it's visible. I am on live student. Thank you. So obviously it is visible. Now see the next one student. Here audio is not there or what? Oh my god. Maybe the audio is being muted. Good. Thank you. So student, first let's see the question number 6.7, right? So which alkyl halide from the following pair would you expect to react more rapidly by SN2 mechanism? Explain your answer. So SN2 student, what is the order of SN2? So it is the 1 degree it will give, then 2 degree, then 3 degree. So here you see this is 1 degree, so it will be faster than 2 degree. So correct, this is the 1 degree now and this is 2 degree. So correct will be answer, this is the first one. Second one, this is the 2 degree and alpha carbon attached with this is the 3 degree. So again it is going to be what student, first one, because this is the 2 degree and this is 3 degree. And now you come here student, this is 1 degree student, this is also 1 degree. But the reason you see student, here bulky group is near to the living group, so it cannot, attack is not possible. So correct will be this one student, bulky group far now student, so easily attack will be possible here student. So this is what. Now go 6.8 student, they are saying SN1 reaction, SN1 order of SN1 student, SN1. So it is 3 degree student, then it is 2 degree, then it is 1 degree, right? So this is the 3 degree student, 3 degree, and this is the 2 degree. So the order will be like that. Here you see student, this is 1 degree and this is 2 degree. So order will be like that student. Now go with the next one, dear student, 6.9. Identify A, B, C, D, E, R, R dash in the following reaction. This is the good question student. They can ask in the board exam, that you have to be prepared. So firstly, reaction of alkyl halide with what student? with the, oh, sorry, alkyl halide is there. You are treating with the what student? Magnesium metal. So if you are treating with the magnesium metal student, so what you are going to get, friend? Okay, if you are treating with the magnesium metal, so magnesium metal, so it will give Grignard reagent. So let's try to write the Grignard reagent, friend. So RMgX is Grignard reagent. So here is what is the Mg, and this side it will be Br. This compound is A. Now treating the Grignard reagent with the water, student. Okay. So what will happen? MgOH Br will be out, student, and here will be the cyclohexane will form, student, and this is MgOH, and this is going to be Br, student, right? This compound is going to be B, right? These things we happened. Now another case is there, RBr, you are treating with the magnesium, student, and here you are taking the dry ether. So again it is going to give the Grignard reagent RMgBr. Okay. Now you are, this compound is going to be C. Now treat with the D2O, student. D2O is heavy water. Now, so what is going to happen, student? RD plus Mg, here will be what, student? OD, and here will be the Br. So this compound is going to be, student, okay. Now here they are saying the compound formed is like that, student. So alkyl group, obviously this R will be what? Something different, student. What is the R will be here, friend? If I write the R, because this compound is already made here, so this is CH3, this is CH, this is CH3, and here is D. It means what, student? This is the compound will be what, student? CH3, right? CH, here is CH3, and here is what? Mg and Br. Okay. So here 1D, so MgOD, so D is coming here, and here is what is the compound, student? CH3, CH, this is CH3, student, and here is Br, and you treat with the Mg, student, so you got here, and this you are treating with D2O, so you got this compound, student, CH, this is the D, and here is CH3. So up to here we solve out, student, right? Now they are saying here Rx you are taking, student, Rx, then Na ether you are taking, so you are getting this one, Wood's reaction, and this Rx if you are taking Mg, so you are going D and E. So very simple, student, very simple. Let's see. So Rx, student, here I am taking CH3, okay, CH, downside CH3, friend, right? Let us see. It should be something like that, student. One more CH3, and here it should be what? Here should be the X. Suppose it is Br. Treating with the 2 sodium metal, student, you take this 2 also. So this will be out now, student. So it is going to give C. Here is, this is like that. So everywhere it will be the CH3, right? This all the places it is going to be CH3, friend. Okay. And now what is the left out, student? 2 NaBr. So this is what is left. Now this RBr, they are saying the same compound you treating with the magnesium, so it will give D, and then it is going to give E. So the same compound you take, student, which one? CH3, C, this is going to be CH3, they are Br. You treat with the magnesium, student. So what you are going to get? You are going to get the Grignard reagent, student. Very simple. CH3, and here is Br. Now this Grignard reagent, if you are treating with what, student? What compound?
they are saying that again you are treating with the H2O student, so that alkane will be formed student, alkane, because Grignard reaction, wait, sorry, here little bit mistake, MgBr it will be there, this is the Mg and here is Br. So you are treating with the Grignard na friend, water H2O. So in the moisture it gives the alkane friend, CH3C. You can match these all the answers. You will find that these all answers are exactly the correct one student. So here is Mg, there will be the OH student. This is the Br. So this is all about the in-text question of the haloalkane and haloarene student. I hope it will be clear to you. Thank you so much for watching friends. Hope it will be helpful to you. Thank you very much. If you want the that is called live classes student, you can also contact with me. Okay, will help